Today we will start a new chapter, current electricity. So we will be dealing only with the basic level for standard 11. Then we will have another electricity chapter for 12th standard and more on JEE. As far as 11th standard is concerned, we will be dealing only with the flow of current, the resistance, the potential difference, how the resistances are connected in series and parallel combinations, mixed resistances, and how do you find the power of delivered by a cell, thermistor, etc. So to start with, we will start a topic that is by definition of resistance, current and potential difference. So first we will understand what is R, that is resistance, current and potential difference. Definition of resistance. Okay. Electricity is related to the dynamic of charges, the dynamic flow of charges. When charge is at rest, we talk about electrostatics. When charge starts moving, it is electricity. When charges move in a conductor, then we say electric current is flowing through the conductor. Now the charges will flow through the conductor whenever there is a potential difference across the conductor. That means to flow the charge in conductor, the conductor must have or develop a property that is called potential difference. If there is no potential difference across the ends of the conductor, then current will not flow, the charge will not move. That means the charge will not move in a definite direction. Now, why potential difference is required? Why not that when we have a closed loop of conductor, why current is not flowing on its own, why the charges are not moving in a particular direction synchronizingly? Because we need to have potential difference for that. We need to have electric field. For the charges to flow, we have to provide electric field. The electric field is provided when the potential difference or a battery is connected. So when a battery is connected, the battery is a device which maintains a potential difference across its ends, two terminals. And if that battery is connected to any conductor, when that battery is connected to the ends of the conductor, then the potential difference of the battery is given to the ends of the conductor. We neglect the resistance of the connecting wires. So whatever is the potential difference across the battery is the potential difference across the conductor. So when potential difference is provided, electric field is set up, because electric field is potential gradient. So we will learn slowly about that, but first of all we will define resistance. That means why potential difference is provided, because to flow a charge, the conductor prevents the flow of charge. The conductor doesn't allow the charges to flow in a particular directions. So that opposition to the flow of charge from one end of the conductor to another end of the conductor, that opposition, that obstruction is called resistance. That means when any charge moves through a conductor, the conductor opposes the flow of charge. That opposition to the flow of charge inside the conductor is called as resistance of the conductor. This means what? That means you have to overcome the resistance in order to flow the charge in the circuit. So to do that, electric field is to be set up, and therefore potential difference is required. So if we'll write the definition of resistance, the definition is, it is the opposition to the flow of charges. It is the opposition to the flow of charges through a conductor. What symbol you are using for this? This is written as ohm. This is the unit of resistance, and resistance you can denote in any letter you like. This is the symbol, is the unit of resistance, ohm. Now the symbol for resistance is R. Mostly it is R. You can take capital R, you can take small r, you can take P, Q, whatever you want. But in this 11th standard we will use only R. R for resistance. This unit is ohm. Symbol is this sigma. Now we'll let us say what is the current, that also will write the definition of current. Current is the rate of flow of charge. To a conductor. Rate of flow of charge flowing per second. So it is q by t or dq by dt. So the unit for current, it is represented with I. I is the symbol used for current. Its unit is ampere. Symbol is A. Okay. Now I will write the formula as q by t. If q amount of charges flows through a conductor, q amount of charge flows through a given area of the conductor in time t, then current is q divided by t, the charge flowing per second. So current is q upon t, if q is the amount of current that is flowing for this time, or if I say delta q amount of current charge is flowing in delta t time, if I give more time to the charge to flow, if I give more time to the charge to flow, then dq by dt represents the average current that will flow. This is the average current that will flow. That means I give more time, so more amount of charge will flow through this cross section. The total charge by total time taken to cross that area. If I want what is the instantaneous current, the instantaneous current is the limiting value of this average. That means I instantaneous is the limiting value of I average. That means what? If I make this time smaller and smaller, then the amount of charges flowing through will be smaller and smaller. Then I can say at a given instant how much charge is flowing. That is the instantaneous current. So I can write I instantaneous as limit delta t tends to 0, delta q by delta t, that is equals to dq by dt. Okay. Now, as I equals to q by t, unit of q is coulomb, unit of t is time in second in SI system. So I can write this: when 1 coulomb of charge will pass in 1 second, then current is said to be 1 ampere. 1 ampere is 1 coulomb of charge flowing through a cross section of a conductor in 1 second. Now, when the charge is flowing, the current is defined, and when the current flows through the conductor opposes the flow, the movement of the charges through the conductor, and therefore resistance comes into picture. The resistance is that will define the opposition. Now, the quantity that is responsible for the flow of the current is the potential difference. Now we'll define potential difference. So let us first define what is a potential by basic definition. We'll also derive the expression for potential in electrostatics. But in this chapter, we are not going to derive the expression for electric potential, but we will take it for granted. But we will derive and discuss in detail in electrostatics. The electric potential is the quantity which is a property of the charge, and like electric field, it is also the property of the charge, and it is a scalar quantity. Electric field, on the other hand, is a vector quantity. How you define a potential? Suppose I have a charge q at a point in space. Then, if the charge is placed at a point in space, just like a mass is placed in space, the mass will have gravitational field around it. Okay, the bigger the mass, greater is the gravitational force, or the gravity will be more powerful if the mass is more. In case of Earth, the gravitational field is because of the huge mass of the Earth, which is 6 into 10 raised to 24 kg nearly, and because of its very heavy mass, it has got a gravitational field which is significant. If I talk about the smaller mass, like an object on the surface of the Earth, like a pen or pencil or any cricket ball, the mass is very much less compared to the mass of the Earth. Therefore, the gravitational field produced by the cricket ball or any smaller mass, is not appreciable. The gravitational field of the ball around it is very insignificant, so it cannot pull other objects towards it. Just like as in case of a Earth, because of its very heavy mass, it pulls the object towards its center. So, as the mass has a gravitational field around it, the charge has electric field around it, and the magnet has magnetic field around it. So when a charge is placed at any point in space, it will have its own electric field surrounding it. And if I bring a unit charge, say 1 coulomb charge, from very far off distance, infinity, to a given point in its gravitational field, then how much work I will do? The amount of work that I do to bring a charge, unit positive charge, from infinity to a given point near the charge, say capital Q, which was earlier placed in the vicinity of that charge q. If I bring a positive charge from infinity and place it, then how much work is done? That amount of work done is called as electric potential. The amount of work that we are doing is stored as in the charge as electric potential. So, and interestingly, the charge that is brought, the potential that is developed at the point is independent of the charge you bring. Okay, the electric field also, because that is work done per unit charge. So whatever amount of charge you bring, the point around the charge only gives you the, it's a point phenomenon. It is the property of the source charge. It is not the property of the test charge that is brought towards the vicinity of the source charge. So that is basically, you have to keep in mind that is basically work done per unit charge. That is the electric potential. So a charge has potential around it and the also electric field around it. So definition of electric potential difference. So if I have a charge, so electric potential is defined as okay. It is defined as the work done in bringing a unit positive charge from infinity to a given point near a source charge. So let us consider a charge q over here is a point charge. It will have its electric field around it. I consider any point here and there is infinity, very far of distance, infinity. I bring a charge, unit positive charge from infinity to this point. Then it will not come automatically because this charge is positive, this is also positive. So we have to do work against this electrostatic force of a person. We will do some work. Whatever work I am doing, that work done is called as per unit charge. Is called as potential. This work done is potential. This work done here is the work done per unit charge. So if I say, so this is the potential now, because here is one unit positive charge. What happens if I bring plus q charge then to this point? Then the potential will be W by Q, work done per unit charge. So actually per unit charge, how much work is done, that is the potential. So it has nothing to do with the amount of charge you are bringing. It is only interested in the work done per unit charge. And you must also notice that the work done is part independent because it depends on the initial and final points, because these are conservative forces. So part independent, and we'll discuss that more in detail in electrostatics chapter. But here for the time being, we only want to know the potential. What is electric potential? Electric potential is a work done per unit charge. In so what do you mean by the difference, potential difference? So that means if I have a point here, another point here, this point has potential say VA, this point is A, and this point is B. This point has potential VA, this point has potential VB. Then I say VA minus VB. I write this as VAV because it is a difference of the two potentials. So this is called potential difference. Okay, so this is the potential difference between the two points. In case of a battery, when the battery is connected across the conductor, whatever potential is developed at one end and at the other end, suppose that two ends are having potential VA and VB, the difference is called potential difference VAB, and in most of the time we write only V. In place of VAB we only write V. V basically in current electricity, V basically means the potential difference, and it is not the potential. It is never the potential, it is the potential difference. So this is how defined, and its unit will be the unit of work and the unit of charge. The unit of work is joule in SI system, and the charge is coulomb, so it is joule per coulomb. That also is called as volt. So 1 joule per coulomb. That means potential at a point is said to be 1 volt. If I bring a 1 coulomb of charge and place at a point and I do 1 joule of work, then that point has potential equals to 1 volt. So this is what is the definitions of these three: resistance, current, and potential. Okay, thank you.